Assalamualaikum and hello. Okay, meet me again, Madam Fauza, in our second part 2 of lecture 11, Basic Data Structure. Go for the course team F1414, Introduction to Programming. Okay, so the topic for today is Basic Data Structure. Okay, so a structure is sometimes referred to as aggregates, okay, which are collections of related variable, okay, under one name. Okay, structure may contain variable, okay, of many different data types. Just to recall back what we have studied in our part 1 video of basic data structure. Okay, remember, structure may contain variables, okay, various variable with many, okay, different data type, in contrast to array that contain only element of the same data type. Okay, structures are commonly used to define records to be stored in files. Okay, for files, which is file processing, we'll cover that in our lecture 12, the last lecture. And pointer, okay, which we have pointers, okay, and structure we'll cover in this topic, part 2. Okay, the pointers and structures facilitate the formation of more complex data structures such as the linked list, queues, stacks, and trees. Okay, so this more advanced topic on linked list, queues, stack, and trees will be covered in another course, okay, which is called data structure and algorithm, okay, in your first year, second semester. Okay, let us go through part 2. Okay, before that, okay, we want to see the list of topic that we covered in part 1 and part 2. Okay, for part 1, okay, we covered in our part 1 video, which is introduction to structures, defining structures, processing a structure, okay, user defined data types, which is type definition. Okay, and for part 2, okay, we'll cover, okay, on the passing structures to functions, okay, which includes the pointers, okay, the functions, okay, and lastly self-referential structures. Okay, let us have start on part 2. Structure and pointer. Okay, remember we have learned that the pointer in a variable is a variable which points to the address of another variable of any data type like integer, character, float, double, etc. Similarly, we can have a pointer to a structure as well, where a pointer variable can point to the address of a structure variable. Okay, here, okay, is how we can declare a pointer to a structure variable. Okay, we see that if a variable represents a structure type variable, okay, then, okay, we can assign us the address of variable represent the starting address of that variable. Okay, therefore, okay, a pointer can be declared for that particular structure, okay, where we can declare it as a structure and all list out all the members, okay, of that structure. Okay, then we have the pointer to that variable of this structure. And okay, how you can assess it. Okay, remember, okay, when we assess a member of that structure, we use dot. Okay, dot. But for a pointer, okay, we assess the member of a structure by using, okay, the sign, the arrow sign. Okay, a pointer variable, okay, pointer variable, okay, and points to the member, so that we can assess this member by using the arrow sign. Let us see the example. Okay, given three lists of variable, we have integer, account number, okay, the character, account type, okay, so double balance. So this is the it's not a struct, okay, so these are three variables outside from the struct. So what inside the struct, okay, is only four, okay, members, okay, which we have account number, okay, a pointer of account number, a pointer of account type, okay, a pointer of a name, and a pointer of a balance. And we have two variable, okay, struct record here, customer and p customer, the pointer of this customer equal to the address of the customer. Okay, Then we point to this customer variable. So these are all the customers pointing here. Okay, point to account number. Okay, account number. Then you have account type. Okay, address of account type. Then you have the name. Okay, we have all the variables Smith. Okay, you have balance and the address of the balance. Okay, why we use this address of? Okay, because the data are set from the struct, which is account number, account type, and the balance. Okay, then we print out. Okay, when we want to access this struct, okay, we use dot sign. Okay, whenever that members of the inner and the members of a struct, we can use dot sign. Okay, for a pointer, okay, which is account number, account type, and balance. Okay, the outside data, outside members, or just a variable, okay, of data. Okay, we use the arrow sign. Okay, this PC here. Okay, pointer customer, account number, okay, account type, name, and the balance. Okay, and we have this data. So you can either use dot sign, okay, for to access the members, okay, and or you can use the pointer, okay, this arrow sign. Okay, so operations on structure variables. Okay, these are the following operation which permitted, okay, on structure variable. First, copying the content of a structure variable to another structure variable. Okay, copying content, okay, which is the members, okay, or the data members of a structure variable to another structure variable, provided both are the same structure type. Okay, they are the same data types as well. Okay, with the type of perhaps character to character, okay, to another structure. Okay, or integer. Okay, same integer character data types. Then passing structure variable or the members to the function. Okay, you can pass the variables, okay, to the members, okay, by using the function. Copying content between structure. Okay, that you can also do. Okay, when you have two or more same structure type. Okay, where structure tag 1, okay, we have the members. Okay, they have the variable, okay, 1, variable 2, then it can be equivalence, variable 1 equal to variable 2. So these are the valid operation. So passing structure to a function. There are several ways to pass structure type information to or from a function. Okay, data can be passed function by either individual, okay, members, or even the entire members in the structure. So individual structure members treated as ordinary single valued variable and can be passed to a function as argument in the function call. Okay, usually in call by reference. Let us see the example given to pass. Given two example. Okay, but first we look at the individual passing individual members of a structure. Okay, we declare, okay, our function, okay, called adjust, okay, float, okay, of type float, okay, passing the float data types, okay, called adjust. We pass three parameters or types here, which is character, okay, integer, and float. Okay, and we have structure called record, okay, which carries four members: name, account number, account type, and the balance. Okay, this is the main function, the body of the function. Okay, the main record customer. Okay, so this is the data, okay, the record before adjustment using individual pass. Okay, so you print out record before adjustment using individual pass. Okay, it's printed. Okay, printf, and this the calling function. Okay, you have the customer because this is your record. Okay, the name, okay, the tag name of the struct. Okay, and this is a variable customer. Okay, so customer dot name. Okay, and this is the name. So we call Smith. Okay, they have account number 333. Okay, account type C. Okay, they have balance. So this will be printed. Okay, then it goes to customer.balance. Okay, so these the members. Okay, balance. Okay, float. Okay, adjust. Okay, function adjust carries three parameters or variable. You have the customer.name, remember you have character for name. Okay, then account number integer. Okay, then float. Okay, balance float. Okay, and goes you have to search for the adjust function. Okay, adjust function. Okay, adjust function here, so it carries three parameters, three variable: name, account number, float balance. And this name is type of this is a pointer. Then float new balance. Okay, 30.02. Okay, the original before adjustment is 33.33. So now you want to adjust it to become 30.02. Okay, and return new balance. Okay, you need to return the new balance so that it will retrieve the customer dot balance, and you will print out the customer dot balance a new adjustment. Okay, this is the original Smith 33C, and the new adjustment will be 30.02 from 33.33. So just a single where the affected members is float balance. Okay, let's see passing the whole member of a structure. Okay, so these are the simulation, how it's affected. Okay, this is example of passing the whole structure. Okay, for this example, okay, we use type definition struct. Okay, for a shortcut for it. Okay, to ease us. Okay, so type definition struct. Okay, character. Okay, you have four here: character, the pointer, name, account number, account type, balance. Okay, then type definition. Okay, variable, call it record. Okay, then you declare. Okay, this is the adjust. Okay, you adjust record. Okay, a pointer. So this is the new one. The whole program will be affected after adjustment. Okay, like in previous slide, okay, previous example, it's only affected the balance. Okay, and kept the three data. Okay, okay, let's see. You go to the integer main. Okay, static record customer. Okay, so this is record. Okay, so a type definition record. Okay, and call the new variable customer. Okay, it carries the name. Okay, 33, account number, the type, okay, and the balance. Okay, and you print it out. Okay, you print record before adjustment to function. Okay, record before adjustment to function. Okay, so this will be printed. Okay, before adjustment. Okay, this is how you call it, by using dot sign. Okay, customer dot account number. Okay, customer. Okay, dot account number, customer dot name, type, and balance. Okay, then you call. Okay, for the whole members. Okay, you use the address customer. Okay, this the address of. Okay, you have adjust, address of. So this will bring the whole members of the structure. Okay, adjust, record. Okay, make sure you call for the record. Okay, so this record represent the type definition. Okay, and then you need the pointer. Okay, class pointer. Then you use the arrow sign here. Pointer, point to name. Okay, Jones. Okay, pointer, point to account number. Okay, pointer, account type, change to R. Okay, pointer, point to balance. Okay, 99.99. So it will get affected when you print out record after adjustment passing to the function. So these are the new adjustment record. Okay, just by using the whole address of the customer. So this is how it shows in simulation. Okay, Okay, what about array? Okay, in a structure program, okay, we call it multiple block data in structures. So one structure only can store one particular block of data as in one array. But how about a multiple block of data? Okay, usually in array, which we have learned in our previous lecture, okay, in array we have multi-dimensional array. Okay, we have 2, 3 multi-dimensional array. Okay, in structure, yes, we also use, okay, we can use a structure array or structure of data that link to each other through a pointer. We use a pointer. Anything related to uh, the data, okay, we can use a pointer. Structure of a data that link to each other through a pointer, also known as self referential structure. Okay, self referential structure, or we call it linked list. Okay, linked list. Okay, you will learn this. Okay, term. Okay, this concept in semester 1, semester 2, year 1. Okay, in a course called Data Structure and Algorithm. Okay, let us look at this example. Okay, we're using type definition struct to declare, okay, our structure. Okay, and record is a variable type definition. Okay, we have name, account number, account type, and balance. Okay, so these are, so you're familiar with this representation. Okay, so you have static, okay, record, okay, this record here, okay, and you name your customer array. Okay, you have 3 list. Okay, you have Smith, Jones, and Brown. Okay, records. Then integer, account number. Then record, okay, the pointer. Okay, you have printf account record. Okay, so for array, definitely, okay, don't forget to include the for loop, because we have 3 records here. Okay, you call for 3 record. Then this pointer, okay, equal to, okay, the address of the customer, okay, account number. So this account number is actually the counter. Okay, account number is the counter. Then you use, because you are using a pointer, remember, okay, you can use the arrow sign. Okay, pointer point to the name, pointer point to the account number, pointer point to account type, and pointer point to the balance. Okay, and it will shows this data. You have account record. Okay, and then it will keep looping. Okay, shows all the recorded static, okay, data, okay, which was specified in the program. Okay, this is the structure array. A self-referential structure, or other words, a linked list, okay, is a structure that has a link, okay, or pointer to address of the next data that have the same structure. So this self-referential structure contain a pointer members that point, okay, to a structure, okay, of the same structure type. For example, okay, we have, okay, struct data list, okay, integer data. We have the struct, okay, data struct node. Okay, so this example. So we have the definition of struct, okay, the struct name data list. Okay, we have integer data. Okay, we have struct, okay, data list, okay, next pointer. Okay, this is the next pointer. So in definition, define a type structure, okay, data list, okay, a structure of type structure data list, okay, has 2 member, okay, which is the integer member data and a pointer member next pointer. Member next pointer points to a structure of type struct node, okay, a structure of the same type as the one being declared. Okay, hence the term self-referential, okay, structure, okay, which is the member next pointer. Okay, this is the next pointer. Okay, is referred to the link, okay, such as, okay, the next pointer can be used to tie a structure of type structure nodes to another structure of the same type. Okay, so this self-referential structure can be linked together to form a useful data structure, okay, such as the list, okay, queues, stacks, and trees, okay, which we learn in semester 2, year 1. Okay, so like for example, okay, this structure have a member that has the same structure as its own. Okay, like for example, we have the head, so we have the address of data. Okay, data. Okay, you can go next. Okay, with the new data. Okay, so this is the next. Okay, with this address here. Okay, so these are all the pointers. That's it, all the data. Okay. So for example, given here, okay, whenever you want to use this self-referential structure, you use a struct tag, okay, data type, the member, okay, and then you need to declare the struct tag, the pointer for a variable, for the next, okay, variable. So this is how you use it. Okay, self-referential structure. So this self-referential structure allows data to link together and provide flexible operation and organization on the data. So detail on this self-referential or linked list will be taught in data structure and algorithm TMF 1434 in semester 2, year 1. Next topic is on union. A union is a derived data type structure with members that share the same storage. Okay. For different situations in a program, some variable may not be relevant, but other variables are. So a union shares space. Instead of wasting storage on variables that are not being used. The member of a union can be of any type. So the number of bytes used to store a union must be at least enough to hold the largest member. Okay, so for the union, okay, define as similar ways as the structure. So the difference is that the union creates only one memory space. So the size of memory computed by the maximum size of its data members. For example, we have union of a student. Okay, we have integer ID, okay, character name, okay, float, okay, GPA, and this is your union 1, okay, variable for union 1. Okay, let us look at this example to compare, okay, the size of, okay, space memory that we used, okay, in bytes. Okay, we use union job, okay, and then struct job 1. Okay, let's see for union job, you have three types, three members. Okay, these three members, name, salary, and work. Okay, same with the job 1 for struct. Okay, three members as well. Okay, represent it with S. Okay, as variable for the struct and U for union job. Okay, let us see how the size, okay, memory allocation, okay, how many bytes allocate for each of the character. Okay, for example, okay, this is the size of character, each of how many bytes, okay, for character, okay, how many bytes for the float and integer. We have 32, okay, for the character, okay, and for the integer is 4, okay, for the float salary is 4, okay, for bytes, okay, for the float for the integer worker number, for bytes we have character, okay, represent by 32 bytes, okay, float 4 bytes, okay, for integer 4 bytes. Okay, then we want to see, okay, how the memory allocation, okay, in case of the union. okay, this is U for union, size of, okay, and then the size of a struct we compared. Okay, from here you can see the result. Okay, for union is 32 and for struct is 40. The union helped to decrease, okay, the usage of memory. Okay, so that's why, okay, we would prefer to use union, okay, for a memory location, okay, to save, okay, to keep the space, okay, of memory. So let us see this example. Okay, what is the output, okay, of this statement? Okay, we have U1, okay, which is the union 1, okay, dot ID equal to 100. Okay, you have U1, okay, union 1, okay, variable dot GPA is equal to 3.75. Okay, printf, okay, should be smaller letter printf, okay, then you call for this integer and float, okay, u1 dot id and u1 dot GPA. Okay, you can pause this video, okay, and answer this question. Okay, let us see the answer. Okay, so the output is garbage value, okay, which is 3.75. Okay, so union variable save the latest assignment of its member. Okay, so it's safe. Okay, this is the garbage value. Okay, and this is the U1 GPA, so it's only print out 3.75. Okay, so this union save the latest, okay, the latest one, okay, assignment of its member. So we'll show you how it works. So we have the ID, okay, 100, okay, and memory 10 bytes. Okay, and you have the GPA 3.75, okay, using the memory of 10 bytes. And the output, okay, garbage value, okay, for ID, and Y 3.75 for the GPA. Okay, let us see example 1 for union program. Okay, you have the union data, 3 members, okay, integer num, float number, and string. Okay, your call for the union, okay, this is your data, okay, and okay, you self-declared data variable, okay, for type of data union, okay, you have data dot the float number equal to, okay, the float data is 220.5. You string copy, okay, string copy the C programming to the string, okay, data dot string, which is this one here, okay, then okay, you print f, okay, the data dot integer, okay, so for the integer number, for the float number, okay, and lastly is for the character string, okay, string. So you have, okay, you print f, okay, this data dot integer num, okay, and you have, okay, data dot float and the string, okay, so you have integer number 19178536, okay, data dot float number, okay, this float, and the string program is C program. Okay, continues from the previous example, okay, union, okay, why the results are different from the stated data that we have assigned. Okay, it should be show us 10, okay, for integer num, okay, float number 220, okay, and string, C programming have been showed. Okay, the integer num and float number we shows in the previous example 1 now, okay, because they are the garbage number, okay, garbage value. So for this example 2, okay, we have made adjustment, okay, by adding for each of the data value, okay, occur first before we do printf. Okay, like for example, we have union data, okay, as data, okay, then we call for data.integer num equal to 10, okay, we straight away do the printf. Okay, not like the previous example, okay, we collected all the data integer num, all the data into one, the early, okay, before printf, okay, collect data.integer num, data.float number, and string copy at first, okay, but for this time, okay, we accompany, okay, after we declare the data value, okay, then we do printf, okay, call function, okay, we list the data for float number, okay, call printf, okay, and then string copy, okay, then we printf, okay, so that, okay, the result, okay, will print, okay, the way that we want, okay, which is the data that we have specified in our program. Okay, this actually to help, okay, this union help us to specify and kept, okay, the space, okay, specific space for required data that we have assigned. So we have allocated 3 space for integer, for float, and for the character string. Okay, then it's allocated only for these spaces. Okay. Okay, we have finally we have entered the last page of our lecture 11 on basic data structure, okay, which include the union as well. Okay, so we have covered introduction to structure, definition of structure, okay, processing structure, and user defined data types in the first video, part 1 of lecture 11, okay, basic data structure. And for this video, okay, which is part 2 of basic data structure, we cover passing a structure to function, self-referential structure, and as well as the union with the last topic. Okay, I think that's all for today on the topic of basic data structure. Okay, the next topic we'll cover, okay, will be on file operation. Thank you.